Hello coders. This, um, I don't really even know what I was about to say. Um, so this is my new YouTube channel. In order to show you like the basics of coding, but, well, not the basics, to show you what's happening at the most basic level, as I said in my channel description. So today, we're going to be showing you what's really happening when you're coding in assembly and how to get started. So I won't show you the setup in today's video, but I'll show you more of what assembly deals with and memory and stuff like that. So I'm going to be showing you a piece of code in this area, and then I will be explaining it over here. So memory is your computer's way of storing information. So you might have like a 1, a 2, and a 4. Memory has specific addresses that are in a certain range. So these are called memory addresses. These aren't real ones, these are examples. But I'll show a piece of C code up here. The way a memory address works is it remains constant. It's always the same thing, but the number it points to might change. So we'll say this is a 1, and in the C code that I'm showing, this isn't the real memory address I'm dealing with, but this is just an example because memory addresses are very long, and I don't want to have to write that. So let's say I put a 1 into it, as I do in the C code, and then, so I then put a 2 into it, but throughout the entire lifetime, this memory address never changes. You can have like different memory addresses. You can have 0x001, but that is a completely different thing from this one. So that's what assembly is doing at the most basic level. It's dealing with memory, and it's dealing with your computer's hardware. So now I'm going to be showing you how assembly works and functions and stuff. So assembly has these things called registers, and they're part of the CPU. And there's more than 4. So each one of these blocks is a register. And like I said, there's more than 4. And a register looks more like this. And I'll show you why in a minute. Actually, I'll show you why right now. So we're going to do the same familiar box, although this time it's not really dealing with memory. So this is called the RAX register. And this, we're actually going to move it because I'm going to be doing a lot of writing. The RAX register is this entire section. Now this is the EAX register. And then you have the AX register, and I believe it's the AL register. And I'll show a picture on screen of all the different registers. So the reason you have different registers is because assembly was developed to work with every what's it called? To work with like every system. But there's issues with that. Is not all systems are on the same architecture. So what they did is they created different assembly versions for different architecture. And in this series, I'm going to be coding on the 64-bit architecture. So what they did is they limited the registers you can use based on the different version of assembly you're coding on. So if you're coding in 64-bit assembly, you're going to be able to use the RAX register, the EAX register, the AX register, and the AL register. If you're coding on 32-bit assembly, you're going to be able to use the EAX, AX, and AL. If you're coding on 16-bit assembly, my 6 and a B look exactly the same. That's amazing. You're going to be able to use the AX and the AL register. And now finally, 8 bits is going to be just the AL register. And there's multiple registers. You have RAX, RDX, RSI, RDI. You have a ton. So the way assembly works is if it limits the register you use based on the architecture. We can call these different versions. This is the 64-bit version, this is the 32-bit version, this is the 16-bit version, and this is the 8-bit version. So now, I'm going to be talking about how assembly does different things. Because in assembly, you don't really have functions. And I'll show a picture on screen of just a simple program that runs and then immediately quits. So in that program, as you can see, I put 60 into the RAX register because the MOV function, the MOV instruction, these are actually called instructions. So the MOV instruction is short for move, which moves a specific value into a specific place. So place and then value. So that's what it does. So I put 60 into the RAX register, and then in the RDI register, I put, so the RDI register looks the exact same except it doesn't have EAX. It has, I don't know off the top of my head, but it has its equivalent of 32 bits, 16 bits, and 8 bits. I believe it's EDI, DI, and then DL. I believe that's what it is. So I'll write those just for, consistency's sake. RDI and then DL. So in the RDI register, we move 0. So, and then we type an instruction called syscall. And based on your version, I don't know about 16 bits or 8 bits, but I do know that in 32 bits, you would call int 0x10. And if you've coded before, you know int stands for integer. But actually in assembly, int stands for interrupt. And the interrupt, this specific interrupt is calling the kernel. I know 32 bits that it calls this, and I know 64 bits it calls syscall. I'm not 100% sure about 16 bits and 8 bits. It might also be interrupt 0x10. It could also be a different one. I'm not 100% sure. Okay, so the way assembly works is it has a specific value in RAX, and in this case it's 60. But the number in RAX points to the different function you want to use. So RAX would have 60. So quit would have 60. Write, syswrite is what it's actually called, would have 1, and so on and so forth. And there's like 300 of them. RDI. So the way each function works, the way each syscall works is it looks at the value in RAX and then looks at the different registers that it needs. So, for example, the quit function, I'll call it a function, it's not really a function. The quit function needs an exit code in RDI, which is typically 0, but it can really be whatever you want. So RAX for syswrite in the RDI needs the where you want to write it to, and that's also going to be 1, which basically just says the kernel, which basically just says like std out. It just says to write out. So that's basically what that means. So each function looks at the register it needs, and these are well documented for performing different actions. Okay, so as you can see on screen, I put 60 into RAX, I put 0 into RDI, and then I call syscall, which will quit the program. And that's really how you do functions, and that's going to be a lot of your time. That's going to be a lot of your assembly code, or your knowledge with assembly is actually going to be knowing where to put different values to do certain things. So that is the intro to assembly. Next video I will be showing you how to install and set up assembly. And the video after that we will be using some of these to do different things. So that's it for today. Have a great day.